Yes. Okay. So I have started recording. Now again, a formal welcome to the course. So since you are here, you know, it's a, and a very happy new year. Hope it will be safe. Let us see. And since you are here, you know that it's a deep learning course, and it is, the course number is CS60010. Let me introduce myself first. So I am Abir Das. So I am an assistant professor in the CSE department IIT Kharagpur. So I did my PhD from University of California, Riverside, and then to short postdoc stints at UMass Lowell and Boston University. Then again, even shorter stint as an assistant professor at IIIT Delhi. And then I came here at the end of 2018. So I generally work in, computer vision, but computer vision is a big cauldron, so to say. So computer vision actually takes in everything. And computer vision was one of the earliest areas where deep learning applications started. So it gives me the opportunity, at least in this semester, to teach a subject in which I work on also. So that's up to my introduction. I'll be happy to share any information about me if you want later and as the course progresses. So let us go over the logistics. I mean, this introductory class will be mostly on logistics and basically to motivate you why you should study deep learning, and basically what is the typical path, career path that you can take from here from an academics perspective. So this is the first slide on logistics. Okay, so let me make it full screen maybe. This one. Yeah, you can. Yeah, I hope you can see my presentation mode, right? Okay. Okay, let me actually go back because I might sometime need to open the links and so on. The one slide where I have animation, I will make it full screen. Okay, so course name and code, deep learning, CS60010. One thing, okay, just I'm checking whether it's getting recorded. Yeah. So one thing that you can ask me a question anytime. You can just stop me if you have any questions and ask me, right? There is not an issue. Okay, so yeah, so time is Wednesday 11 to 11:55, you know, Thursday, that is 12 to 12:55, and Friday 8 to 9. I don't remember which slot it is, but you guys probably know it. Venue is not, of course, offline. It was going to be offline, but you know the surge, and yeah, again, it's online using Zoom, just like the last semester. This is the course website. I'm not opening the course website now. I will do it probably 1 or 2 slides later. It has a lot of information. We are using mainly a few, I would say, communication channels, I would say, or platforms. One is, of course, Zoom. The other two are Moodle Classroom and Piazza. So you will see that I'm getting rid of Teams. So I don't want to use Teams. There are lots of problems, etc. Let's not go into there. So Zoom will be the lecture delivering platform. Moodle, you know, for taking exams, homeworks, etc. Right? So for this class, I am using the Institute Moodle, which is kgbmoodle.iitkgp.ac.in. And then the class name is this, Deep Learning CS60010 Spring 2022. The thing is that I have not yet added you guys in this Moodle, because I mean, if in the Moodle page for this course, probably you are there in Moodle, you must be there. And if not, just try to register register in this KGP Moodle. Send the mail to the help desk if you face any issues. I think I have given that instruction in the email. Now, Why I have not yet added you guys in this course is because the registration deadline is still 7th, right? So I need to wait for the final registration. Otherwise, I have to send an incremental list always to the admin of the Moodle, and they might not like it. So at the end, finally, I'll send it. And you will not need it before the end of this month. So it's fine. Now, what is Piazza? So Piazza is a communication platform. So let me actually go to Piazza. So if I click it, I mean, I have clicked already. Okay, just 1 second. Here. Yeah, so Piazza, you will probably see the student view. Yeah. So yeah, again, here also I have not added you yet because I think for this week we can do without Piazza. There won't be any important announcement, I hope. If there is, I will just communicate with email. But the idea of using Piazza is to less clutter your inbox, yours as well as mine. So this is a big class, so I hope that there will be confusions, questions, etc. And remember that if you have questions, that means many other people might have the same question. So don't be shy, just ask it here. And I mean, you will get basically quick help here. I mean, you can get. Why I'm telling is that instead of mailing to say just me or the TAs, you are actually mailing it here to everyone in the class, and somebody might have the question answer. So that is the purpose of Piazza. So just create, I mean, yeah, if you go to this welcome to Piazza and just the FAQs, how to do things, helps, etc. there. So just make yourself familiar with it, right? So starting next week, all the communications will be made preferably through this Piazza channel. If there is something very urgent, maybe I can email you, otherwise no. Okay. Let me go back to this again. So let me introduce you to my fantastic team of TAs. So the TA, of course, the team is not only me and the TAs. I mean, a significant portion is you, right? So we are only 6. You are probably 20 times then. Okay, 20-25 times, whatever. So let me introduce the TAs. The TA contact emails are given, but yeah, of course, you should email only if it is pretty urgent. Otherwise, I mean, Piazza should be pretty active. Now, the TAs should be here. I will request you, I mean, the TAs. I'll call your names and I'll request the TAs to introduce yourself. So which year student you are, if you work on any research problem, what are the areas that interests you, those things you can introduce about yourself. And remember, they will be your mostly the first point of contact. The students, they will be the TAs will be your first point of contact. So yeah, and to the TAs, if possible, just flash your video once when you are introducing. I mean, in offline classes, in the very first class, I like to call the TAs and they just stand up and introduce themselves, but it's probably just a proxy for that practice here. So if possible, press your videos. So yeah, Adarsh, can you please introduce yourself?
Hi everyone, my name is Adarsh. I'm a 5th year dual degree student in the Department of Computer Science and Engineering. I majorly work on self-supervised learning and unsupervised learning under the guidance of Professor Abhay Das. And yeah, feel free to reach out to us regarding any issues or any details of the course, and we would be really happy to help you. And yeah, I hope you enjoy a lot and learn a lot in this course. Thank you.
Thanks, Adarsh. Anurag, please. Anurag, you are here? Oh, maybe Anurag is not here.
Here.
Oh, yeah. So please.
Yeah. So Hi, I'm Anurag Roy. I'm a PhD student here at IIT Kharagpur under the supervision of Professor Abid Das and Professor Saptarshi Ghosh. I work on multimodal machine learning. Currently, I'm working on distribution generalization of models, mainly meta learning and continual learning. And yeah, if you have any doubts, you can uh, post your questions on Piazza, and hope you will enjoy the course. Thank you.
Thanks, Anurag. Yeah, Mohammed.
Good morning, everyone. Hope you guys are doing well. I'm Mohammad Ladla. I'm currently pursuing MTech in Computer Science and Engineering department. I'm in second year. I'm currently working on probabilistic programming languages. I have projects on NLP and stuffs including deep learning. So hope we do good things in this course, and yeah, you can reach us. Thank you.
Thanks, Mohammed. Siddhant might not have the bandwidth to switch on the video, but yeah, still, please go on, Siddhant.
Yeah, hello everyone. I'm Siddhant. I'm a final year dual degree student from the computer science department. I mostly work in reinforcement learning, explainable AI, and computer vision. So welcome to the course, and hope you'll have fun in this course. Feel free to reach out to any of us if you have any queries. Stay safe.
Thanks, Siddhant. Deepak, please.
Hello everyone. Hope you all are doing well and welcome to this course. I'm Deepak Mewala. I'm a PhD scholar in Department of Computer Science at IIT Kharagpur, and I'm working on building deep learning model for brain signals. And currently, I'm working on continual learning and transfer learning. And yeah, you can reach out to us if you have anything to ask. Yeah, thank you.
Thanks, Deepak. So yeah, so as I said to the students, they will be your first contact. Please feel free to reach out to them. Okay, before I go to the maybe course website, etc. Yeah, so if you have any questions, friends, till this point, I mean, we will come about the tests, how the marks distribution will be, when they will be, those things. If you have still if you have any questions, please ask. Otherwise, I'll continue. Okay, these are some formalities, of course. Course information, that is prerequisites is machine learning. So you know that, I mean, deep learning is only a subset of machine learning. So we will be giving a kind of thorough view of deep learning. In a sense, it's a thorough view because we are focusing more on a subset of machine learning. So you need the machine learning as one of the prerequisites. Otherwise, it may be tough after, say, initial month to pick on stops. But if you have done it, please just try to brush the concepts up a little bit. I will brush a little bit as required for this course. For example, the simple neural network, that is ANNs and so on, logistic regressions, etc. But please go through your notes for this in the previous course that you have taken. Now, I said that in a sense it is a detailed course on deep learning, but in another sense it is not even. Why I'm telling this? Because deep learning has grown too big. So it's not, I would say, advantageous to maybe dig deep into a small portion of deep learning. Rather, what I will try to do after the initial 1.5 months, 6 weeks or 7 weeks, I'll try to go to more on the applications and give you a flavor of where all deep learning can be employed. And mostly, since this is a very evolving topic, a very evolving subject, things generally change. I mean, the topics that is covered maybe 2-3 years ago, topics significantly change. And if it does not change, then it is bad for the learners, right? So things have come a lot, new things. So I'll just try to throw lights on them And yeah, with of course your help, I'll come to that, how your help is needed. But yeah, I think the fundamental thing is always machine learning. So you need to have a good grasp of it. Python proficiency, I would not say that you need to be an expert in Python, but familiarity with some deep learning tools will help. So it's desirable. So a few links to get started. It's on Python, not the deep learning tools, because yeah, I mean, TensorFlow, PyTorch, they are very popular tools, but for the purpose of our course, we will resort to PyTorch. And you will probably see that PyTorch is the most popular. Probably 90-95% people in deep learning research, they basically do it in PyTorch, unless they need very sophisticated stuff that is supported with TensorFlow or this ONNX, etc. from Amazon and so on. Now, yeah, but don't think that we will give a comprehensive tutorial of PyTorch. We might get you started on one of the extra classes by the TAs, but this is some tool that you need to pick up on. For PyTorch, I think the homeworks, that is the coding assignments, you will need it, but of course not in the tests. Okay. So this is about the prerequisites and Python proficiency. Yeah, this is one I would say mandatory slide that I have to give, but it's probably very less informative. Why? Because yeah, the book is what we will, I would not say mostly, but what we will follow is deep learning, which is by Goodfellow, Benjo, and Corville. But I think this came in 2015 or something, or 16 maybe. This book got published. But after that, a lot of things have changed. So I mean, we might probably follow the structure of the book, but the material will be mostly culled from many literature, basically. So the literature may include actually papers, the blogs, online courses, and I mean, as and when I get basically opportunity, I'll give the sources. I generally tend to I like to give the sources, because yeah, I mean, in a 1 hour lecture, or even say 30, I think I'm getting like 34-hour lecture time this semester. So 34-35-hour lecture time, I would not be, I mean, it is not possible to quote unquote teach a subject, right? So it's basically to rouse your interest, right? So I mean, I'll give these sources. If you are interested in certain topic of it, just go and dig deep into that. So that's the basically idea of the course, right? So these are the main 4 online lectures, at least, that I closely follow. This was the very first one, I would say. I mean, not the first one. If I say the 0th one is the Nando de Freitas, when he was in University of Oxford, now in DeepMind. So that time there were like 15 lectures on deep learning. So that was probably the very first, I would say, on deep learning online courses. Or lectures rather. And that time there was no TensorFlow, PyTorch. Only Torch was there and Theano was there, and those have become obsolete. And it's not like 50 years ago. It's just 5-6 years ago, 2015. So you see how evolving the field is. So I mean, we are all like fortunate to be in this time, right, to study deep learning. So that was the 0th course, if I say, and this first one is a CS231N. I mean, I hope the majority of you at least have watched 1 or 2 lectures of it, if not all. If you have not seen, try to go through it. These are fantastic. And you will see people who gets their hand dirty, they are teaching it, right? So they were the graduate students at that time, and one of the ones were Andre Karpathy. So Karpathy is now Tesla AI head. Karpathy, I mean, it is from Stanford University, so he was a student of Fei-Fei Li. who is actually one of the stalwarts in the field. And from their group, actually, the ImageNet dataset, which we will always probably use. And if you are taking deep learning course, you must have heard the name of ImageNet dataset, right? So anyway, so Andre Karpathy, Justin Johnson, they were the graduate students, and Fefeli only took the first lecture, which is also fantastic, the history of computer vision. So please see that, if not any other lectures. So I'll closely follow the material. So you'll probably get a flavor of that in this course, but not the first lecture. But the first lecture is very important, very interesting. Anyway, the other two that I used to like take inspiration from, I mean, in the previous offerings of the course is Theo Gibbs Deep Learning from University of Amsterdam. The link is given, and NPTEL Deep Learning by PKV here, Praveen Kumar Vishwas at IIT Kharagpur. They are also like some parts I have taken from these two lectures, and I mean, I'll give the source when I will basically discuss those sections. But this one has come out to be, the last one has come out to be a very good one as far as the like current context is going on. So Sergey Levin, this is from UC Berkeley. I think it is called CS 182W or something, the course number, but yeah, the link is given. So Sergey Levin is a fantastic teacher. So he was I mean, he is in reinforcement learning, doing very great stops. The reinforcement learning lectures are also great. So I follow a lot of his lectures when I teach reinforcement learning. And I found that last year, or probably last semester, he actually started teaching this deep learning course, and it's fantastic. I mean, very modern, many new concepts are there, as well as the old ones are very well explained. So I have taken the latter part of the topics from here. So these are the main 4 online courses. If there are any, I mean, anything extra, that I will basically give it in the slides. Okay, before I go to the evaluation, like what will be the evaluation criterion, etc., let me actually no, actually let me do it and then I will go there. Okay, but before that, if there is any question on these part, resources, etc.
Sir, what about people who have taken ML this semester along with deep learning?
That should be fine. That should be fine. Because I think the, I mean, initial part, what I will cover, maybe it will come towards the 8th, 9th week in that in ML course, but it should be fine. If you are taking the ML course parallelly, that should be also fine. Okay.
Okay, thank you, sir.
Any other questions?
Sir, I had a doubt.
Yeah, please.
So, so far, whatever I have done about machine learning or deep learning, I usually used to Google up stuffs and write the codes based on other use cases I found in the net. So is that how we always code in machine learning, deep learning, or?
Not always, not always. Of course, you need to, I mean, Google is there to help, but you need to have your concepts clear also, right? Otherwise, I mean, you can probably do it for product development, etc. That might not be interesting, but it's a subjective view. That might not interest you. But if you are trying to do something new, it's new, right? So Google might not be able to give you the solution. So you need to depend on your intuition, your basics, that is the concepts that you have learned. So of course it is not always true. I mean, I'm not telling about the course in the perspective of the course, but what later you might do, right? Does that answer your question?
Even if we innovate, but then also the coding part remains the same, right?
Coding is just the implementation, right? So experiment. So you have learned about, I mean, in not even high school, probably middle school stuff, that what are the 3-4 stages of experiments, right? So you need to first design the experiment, then you do the experiment, right? So coding is just doing the experiment. That's just the implementation. But to design what you need to do to solve in a research problem, it's not just you can find a solution. So you have some idea, you experimented, okay, I thought, okay, this will work in this way, let's see. That let's see. After that, let's see, the coding part is come. Coding is not at all like the 100% of machine learning, right? It's probably 50%. Some people tend to give even less than that, but yeah, maybe 50%, right? So the rest of the 50% also you need to do, and it's a like procedural term. I mean, it's or rather say sequential. So if that the first 50% is not there, even if you have the last 50%, you may not be able to even go. I mean, you may not be able to progress much in research.
Okay, thank you, sir.
Yeah. Okay. Let me go ahead. If you have any questions later, I will stop. Okay. So I think this is the most important part as far as you guys are concerned. So the evaluation. So how will the evaluation be done? So class test is 3, programming assignment will be 2, and paper presentation 10%. So what is paper presentation, etc. I'll come. So class test and programming assignments, they will have a combination of mathematical and coding problems. So mostly the class tests will have mathematical. If there is any coding assignment, that will be too small, because I know in a like 1 hour class test, even doing a coding problem may not be easy. So just be assured, if there is anything, that will be very trivial. Programming assignments, it will be mostly coding. There might be a small portion of mathematical basically problem. So we are telling it programming assignment, but basically this is homework, and this class test is the quiz, right? So this is 3, so 60%. So basically 20% weight on each of the class tests, programming assignments, I think 15%, and paper presentation 10%. So when will be the class tests? When are the programming assignments? I have some plan. I'll probably tell when we'll give it, but class test dates I have fixed it, and it is there in the website. I'll come to that. Two class tests or 2 quizzes will be on the window, the test window, but one will be earlier. Okay, now what about the paper presentation? So I'll come to the course website probably 2 slides later, and then more information on class test programming assignments will be given. So paper presentation, how it will be first conducted, let me tell. So the whole class will be divided into 2-member teams. Okay, so if there are like 150 students, then 75 teams will be there. The team will be formed by the instructors and the TAs. Papers will be assigned to each team by the instructors and the TAs. So papers will be assigned by us, and teams will also be formed by us. I think in online setting, the other way around is not quite easy. The information will be given to you. The presentations will be outside class hours, because we cannot probably afford to waste class hours. Possibly in the evening. So I think you guys have classes till 6, right? So after 6 p.m. on one day of the week, that is Tuesday, I will announce once the date is fixed, the starting date is fixed. But as of now, Tuesdays 6 p.m. to 7 p.m. Will be that. So exact dates will be announced later. The tentative start of paper presentation will be not mid of February. It will be, let me say mid of February. But it will be actually probably the second week of February. Let me just quickly check. Oh, probably the start of February. Let me just say start of February. So after we have progressed a bit on the course, we will do. I mean, I forgot whether it's, no, I think it's 8th. So maybe mid of February was right. The 8th of February. So I'll communicate about that. The duration of each presentation will be 10 minutes plus 2 minutes of Q&A. So basically in 1 hour, 5 teams will present. Each team will have to present one paper during the whole semester. So that is important. It's not that every Tuesday you need to be mandatorily be present during the after class hours. No, just once in the semester, but all the information will be there in the website, like who is presenting which paper on which day. So if you are, I mean, I'll request you, if this subject interests you, maybe you can visit it. Maybe that, okay, some week I am basically asking people to present on detection papers, and you are interested in detection. So maybe you can try to join. So it's not mandatory, but if it interests you, please join. But once in the semester, it is mandatory when you will present, right? So hopefully that will not like burden you on the after class hours. So just once, that's why I like highlighted this. Now the some thumb rules for the presentation, because I always get these questions. So yeah, I have not I mean, I don't know how to present the research paper, so how to do it. So first of all, if it is 10 minutes, then maximum 10-12 slides. The thumb rule is 1 minute per slide. It can be like say 0.9 minute maximum. So divide the presentation in problem definition. That is, if required, provide importance of the problem. That why is the problem important? Why should one care about solving the problem? Approach, that is, what is the approach that is taken by the authors? If you can motivate why the approach is good or novel, it will be great. So if you can give your inputs that why the approach you think is good or it's novel, people haven't done it earlier and this is making it stand out, then that will be very good. Then you analyze the results and what could have been done extra according to you. If you can give, that will be fantastic, right? So summary, papers will be assigned to you. Team, I mean, the teams will be made, and then you need to present, right? Yeah, I think after this slide, I will stop for questions, because this is also about the paper presentations. So yeah, I mean, why are we doing this? So deep learning is a rapidly evolving field, as I said, and every day new papers are coming out. So just check arXiv. So arXiv.org, probably you know, which is open source, and people basically actually archive it, the papers that they are working on. If that is like substantial work has been done, people need to know about the work, they do it in arXiv. I mean, now at least in deep learning, computer vision, arXiv is a norm. And see, especially just after the paper submission deadlines of reputed conferences. So we will see what are some good conferences in the fields related to deep learning in a few slides. So there are some good conferences, journals. Journals don't have deadlines, but conference is mostly popular venues for submitting your works, communicating your works, right? So after the deadlines, you will see in arXiv. So people have submitted there. Mostly the conferences are what is called double blind. That is, you are sending your paper anonymously, and the reviewers will review it and then give their decision, right? So I will come to the process how generally the conference decisions are made, but I mean, somebody will review, right, and tell that, okay, whether this is good for publication in the conferences. So that basically deadline. So it's a double blind, as I said. So the reviewers don't know your name or who has submitted, and the authors don't know who has reviewed, right? So but that's a confidential thing, so to say. But people are eager to let the world know that, okay, I have done this fantastic thing. And it's always a record. I mean, it's good to keep a record that, okay, I have done these things, because many people are working on the same problem, right? So they may come up with a similar approach. So it's good to keep a record. So that's where archive comes in, and basically people upload it in archive, right? So after the deadline, so that when the paper is ready, they go and upload it in archive. So if you just check how many papers came in archive, there are, like, say, different fields in archive. I mean, you have to tag your paper under which category it belongs. So if you just go for some computer vision and pattern recognition, you will see a lot. Just goes to computer science, you will see a lot. Physics, you will see a lot, and so on. So every day you can see, I think every weekday you can see how many papers came in archive in under these tags. So you will see, I'm telling. Okay, now there are lots of paper, as I said, that are coming. So some of them are good, some are bad. If we divide and conquer the task of reading papers, everybody will be benefited. That's the main motto for this paper presentation, though it's 10%, but just don't go by this 10%. If this field interests you, you have to read papers, nothing doing. Okay, and you have many other things to do, many courses to take, comprehensive viva to give, and so on, right? So if somebody else reads the paper and just summarize it for you, that will be good, right? So that's the idea. Papers are big things. So how do I get started? If you don't have an experience of reading papers, or even if you have an experience how to actually be good in reading papers, there are fantastic tips by Andrew Ng. I'm not going to tell what it is there. So this talk, again, I mean, it's not Andrew Ng, it's Andrew N, the pronunciation. So Andrew N has this talk. I mean, I think it is a 1-hour talk in one of his courses, but the first 30 minutes discusses about this, and the last 30 minutes, I think, probably some connections to industrial research and so on. So I'll urge you guys to look into this. Now the course website. So the tentative syllabus and schedule. So a tentative schedule is posted in this website. So let me go to the website. Yeah, so this is the course website from where the screenshot has been taken about the TAs and so on. You will find the links here, right? So for example, if you click on Adarsh's name, he will go to his web page or the LinkedIn profile, and you can know about him, like what works he has done. Students presentation schedule does not have anything now, but you can go into the previous versions of the offering and you can see how it generally happens, but I'm not going into that as of now. Okay, I'll go to this detailed course syllabus, but these are class time, location, emails are given here. Have questions, then Piazza, basically. I hope the link is here, right? Yeah, of course, the website design is inspired from CS231 in course page, which I again said admire a lot. Now, if I go to the detailed course syllabus, you will see a tentative syllabus. Of course, I mean, this might change a little bit, but mostly it will remain same because, okay, I mean, we might not complete one, like maybe something that we thought of completing in like 5 lectures. If it goes to 5.5, then things will change accordingly, right? So, or even if I can complete it in 4.5, I can start this in early. So this is something that can happen. So the whole plan is given. The slides for at least the first 2 lectures are up. The other slides will be coming. At least I will try to upload them early. That is, at the start of each module, I'll start. I'm planning to upload them. If it does not happen, it will definitely come after the class, right? Now videos, so the links of the recorded videos will come here. So it will appear here as and when the classes are done. Okay, so now let me go back to the, okay, the course website I have given the link to in the email. I'll also add it to my homepage. Yeah, so this is the last slide before I take questions. I will have to cover a bit on the conferences. So what about the computing resources? So you know that deep learning requires lots of computing resources, but yeah, we are lacking computing resources here at IIT Kharagpur for these big classes. I am trying a lot with a lot of people. Maybe you guys, when you guys go to industry, just flood some money so that your juniors can get some computing resources. But yeah, that's in future. So we are encouraging you to use Google Colab. It's free. Homeworks can be done in your PC and Google Colab. Probably in your PC is a too far-fetched dream, but Google Colab for sure. We are planning to arrange a tutorial session to get you started on Colab and some basics of Python, where just Colab, how to use Colab, some basics of Python or PyTorch, this will be given. We will plan it accordingly when to do. We are also trying for some free credits, GCP credits, Google Cloud Platform. Previous experiences of us is that they just give very small amount of credit, $50, and for that you have to have a lot of headache. You need to remember to stop the instances, blah blah, many things are there, but still it's good to have something, because one of the disadvantages of Colab is that it gets, since it is free, it is not, there is a professional account option of Google Colab, but yeah, of course it charges money. So I would not suggest you to do that. I cannot rather. The free part, the free account, it has some glitches. It probably does not allow you to run a program continuously more than 12 hours. I'm not totally sure that ES can confirm. So if you have GCP credits and suppose your training needs to be done for a day or say 2 days, that will probably help. Again, why I'm telling probably, because running probably these GCP instances for continuously 2 days will eat up whatever free credits that they provide as an academic initiative, which is only $50. But yeah, these will come later. So I just thought of covering this. Before I go to tell you about computer vision conferences, encourage you to submit your work, do some research work. If there is any questions on this part, mainly the logistics parts is what I had to tell is done. If there is any question. Anyone on tests? Lectures, nothing? Okay, if not, then as I promised, these are some computer vision conferences. So CVPR is the topmost conference, not in computer vision, not in machine learning. No, not only in machine learning or not only in computer vision, but across, and not even in, it's the topmost conference in computer science. But if you take into consideration any field of study, basically, it can be humanities, it can be science, anything. It is the fourth one at this point, so top 4. And how am I measuring it? It is using some Google Scholar metric, which is called H5 index. Which means that in the last 5 years, at least this many papers have had at least these many citations from this conference. So the higher the better, and it's big. I think the topmost one is somewhere around 400, 399 or something. Science, Nature, you guys know those names, but CVPR is soon reaching there. So CVPR is generally held in USA. It's an international conference, of course. However, 2023 is scheduled to be held in Vancouver, first time outside USA. So, generally these are exotic places. So if you have a paper, it's not only prestigious, but you have chances to go there. So I'll come to a fun slide on how to decide to submit to which conferences. Then these two, ICCV and ECCV, which is International Conference on Computer Vision and European Conference on Computer Vision, they are biennial. So every alternate year they happen. So these are ICCV happens in odd years and ECCV happens in even years. So this is an even year. So this time it is the ECCV will be happening. I think it is somewhere in Israel or Turkey, somewhere in Istanbul. Okay, this time I need to check. Or I think Turkey, probably. Tel Aviv, Israel, right? Anyway, so these are the values. So Google Scholar H5 Index in 2022, you can see verify. Organized under the banner of Computer Vision Foundation. So what is Computer Vision Foundation? It's basically an organization or association of computer vision scientists, right? They basically make the policies and so on. So you can have a look. There are other conferences other than these. So ACCV is Asian Conference on Computer Vision, BMBC is British Conference, ICP is International Conference on Image Processing. It's one of the oldest one. It's pretty prestigious, but it accepts papers which are less lengthy, that is 4-page. WACB is also that, Workshop on Applications of Computer Vision. All these, I think ICP and WACB are IEEE one. ICP I don't remember, International Conference on Pattern Recognition, and then ICB GIP and NCB PRIPG, they are national conferences, so Indian conferences. All these are pretty good. There are journals. So not only conferences, the journals are also very prestigious. Some countries have culturally biased towards publishing in journals. Some countries have conferences. In our, not only countries, even fields. So in our field, the bias is towards conferences. There are many reasons. I'm not going into detail of it, but one of the thing is the easy or quick turnaround time for conferences. That is, you get the review that accept decision or reject decision pretty early. But there are pitfalls on that also. The reviews can be noisy also. Anyway, so these are the, I think, top 3 journals in computer vision. PAMI is Transactions on Pattern Analysis and Machine Intelligence. TIP is Transactions on Image Processing. And IJCV is International Journal of Computer Vision. These are IEEE, and IJCV is probably Elsevier. Other than H5 index, somebody has any question? Okay, other than H5 index, the impact factor is one of the metric to judge. Like, I mean, of course, I mean, these are very much subjective, how good it is and so on. But these are some accepted ones, I would say, not universally accepted, but accepted metrics. So the higher, the better. I'm not going into detail how it is computed and so on, right? Conferences in other application areas. So deep learning is not only about computer vision. So other application areas, for example, NeurIPS is, I mean, you can get computer vision, natural language processing, even theoretical machine learning, many things. So NeurIPS is, I think, 12th across any field, any conference or journal. MICAI is on medical imaging. ICLR is International Conference on Learning Representations. And this is one very, I mean, this is one conference which has meteoric rise, which has seen meteoric rise. There are like, I mean, very good scientists behind this conference, starting this conference. They have started a lot of new things, open reviewing and so on. Anyway, so it is it has started in only 2013, and it is 10th across any field, any conference or journal according to this H5 index, right? ICML is International Conference on Machine Learning. Then ACLM and NLP, these are on natural language processing. Then these are many others, right? I'm not going to tell like the full form of this, right? Journals in other applications areas, likewise, TMM is on multimedia, JMLR is Journal of Machine Learning Research, very prestigious, very tough to get in. KD, Knowledge and Data Engineering, then TCSVT, CVIU, IGRR, etc. CVIU is Computer Vision and Image Understanding. This is Transactions on Circuit Systems and Video Technology. IGRR, I don't remember. Now, if I go to, yeah, so this is the fun slide. Let me go to this. Yeah. So should you, I mean, I'll just read one or two maybe. Should you submit a paper to the conference? So first question you ask, is the conference in an exotic location? If it is yes, do you have new data to present? Just straight away go to, do you have money in the budget? So it depends on, do you have money in the budget? Because of course, these exotic locations you can go, then stay in a hotel and so on, registration fee, etc. It must come from some project or your advisor's project or the institute. So that is meant by, do you have money in the budget? But I mean, you can even submit if it is not in an exotic location. Then is it relevant to your field? Maybe. Then can you make it sound like it's relevant to your field? Yes. Then how much can you reuse data from a previous paper? If you can reuse just, yes, you can do that. Are all your office mates going? So you can have a good fun holiday. Then so you can just look into these parts. I mean, this is taken from PhD Comics. So PhD Comics is a good repository of making fun of PhD students, right? So okay. Yeah. So yeah, 1 second. Yeah, so that's a fun slide where to submit. Now again I have to go to slide. So yeah, this is the slide which tells how a decision is made in a conference submission, right? So there are the program chairs who are the kind of the heads of the these are generally very big names in the field. Then these PCs or program chairs, they assign papers to ACs. So when the authors have submitted the paper, these papers first goes to the program chairs. They assign these to ACs. What is AC? AC is an area chair. Now, this term is a legacy term. So suppose in deep learning, there are many application areas, say detection, say segmentation, say domain adaptation. So these areas are represented by some persons or some scientists. So some scientists work mostly on domain adaptation, say. So he will be an area chair for the domain adaptation papers. So it might not be just one PC for, one area chair for domain adaptation. There may be many, because many good and senior scientists are there in, say, domain adaptation. So this term is coming from a legacy. I mean, this generally used to happen, but nowadays many people work on many problems. So there is no one-to-one mapping for these areas and area chairs. So just say that, I mean, think of it as another like level in the hierarchy. So it goes to one of the primary area chairs. So why there is a primary term, I'll come later. Primary area chair suggests reviewer. So then the area chair who works in, say, domain adaptation, he knows who works in domain adaptation, the young scientists, young professors, okay, young graduate students. So they basically assign them to the reviewers, those persons. Papers are assigned to the reviewers using a global matching algorithm. So there is, because of course, I mean, if there are 10,000 papers submitted, the area chair will not, or the program chair will not read all of them, or area chair, generally one area chair gets like 40 papers to handle. So it is hard to read all of them and then assign. So maybe the abstract they read and then get an idea which from the title, and these terms are important, title, abstract. Why I am telling this, it will come in the next slide. So by reading that, they assign it to the reviewers, and of course there is this automated algorithm. I mean, generally some NLP sort of algorithm. Okay, what are the interests of that reviewer and what things are told in this paper? Just try to match, and then of course these people verify. I mean, these primary area chairs. Then it goes to the reviewers. Reviewers read this paper, give their comments, write their reviews, which are released to the authors. So authors will now read their review of their paper. They will write their responses, which are called rebuttals to the reviewers. I mean, generally this happens within authors and reviewers, but ACs are in loop. Okay. Now, the sixth process is that reviewers update the final review. So after reading the responses from the author, the reviewer might have some questions. Okay, why did you not do this experiment, or have you seen this paper? This might have done a similar thing, and so on. So after reading their responses, they update their final review and recommendation, whether it should be accepted, why, and so on. So then it goes to both primary chair and secondary area chair. So secondary area chair is one who is a kind of parallelly, he will see what are the decisions made, what are the communications made from this point onwards, right? So it does not see before this. So just another senior scientist. Now, area chairs discuss, now the primary area chair and secondary area chair discuss with reviewers and each other also, that is both the area chairs, and make accept reject decisions and oral recommendations. So in conferences, you have some poster and oral, right? So orals are supposed to be more significant. they are invited to go there and present their work. That is a 10-12 minutes presentation, and that's where this presentation will help you, right? It will prepare you how to present. And so then it goes to the program chair, and program chair notifies the decision. So that's basically the way it happens. Now, yeah, so okay, program chair finalizes and based on space-time constants. Now, this is probably the last slide. This is so how to write a good paper so that it gets accepted, right? So Jitendra Malik is one of the famous scientists, and he's in UC Berkeley and also Facebook AI Research. I mean, he actually did his BTech from IIT Kanpur, right? And then in the US he done PhD and so on. So, but he's a stalwart, and he basically talks very good. I mean, his talks, if you want to, I mean, if you listen, you will learn a lot. And he gave this talk in I think CVPR 18. There is a workshop, how to be a good citizen of the CVPR community, and this is how to write a good paper. And one of the I mean, things, the very important things that he told, and it stayed in my mind. Actually, when I was just preparing for this lecture yesterday, I again saw it yesterday. It's a 20-minute lecture. I mean, in this workshop, the very first talk. There are other interesting talks also. So one thing he said that so you cannot make good wines from bad grapes, but you can make bad wines from good grapes. So to write a good paper, first thing you need is a good work, right? So given that you have a good work, I mean, there can be bad paper you can write or a good paper you can write. So how to write a good paper given that you have a good work? So it's not always that you have a good work and you write something and it gets accepted. And for that, there are many tips that he gave, but one of them is that stays in my mind, and I agree, is he said that there are 4 important parts in the paper. So title, abstract, introduction, and rest of the paper. And you should give equal time to writing everything. So title, abstract, and introduction, probably it's just the first 2 pages, and maybe the rest of the pages, 8-9 pages or 6-7 pages are on the rest of the things. And actually the rest of the things is where you tell what you did exactly, what are the experimental results. But that is very simple to do. Okay, what you have done, you tell. What your results are, you tell in a, of course, lucid way. But if your title is not, I would say, memorable, if it does not interest your reviewer, you might be in a disadvantageous position. Abstract should always be very expressive, I would say, what you have done, what actually it means is means by the word abstract. Because you see, the program chairs, area chairs, they might just read the abstract to suggest a reviewer. So if your abstract does not convey what you have done very, very precisely, it might go to a wrong reviewer who does not work in there. So you are then doomed. And in introduction, that is for the reviewer. So the reviewer, so the first impression is almost always the last impression, right? So if the paper is likened by a reviewer by just reading the introduction, it will stay there unless you have done some blunders, some very, very huge blunders in the methodology or in the experiment section, right? At least that happens to me as a reviewer. And so when you are as an author, or I am an author, I need to like put the reviewer's on and see how can I make the life of the reviewer easy, right? So I would urge you to basically go through this, and yeah, I think I have spilled the time a little bit, 12:03. Thanks a lot. Any questions? I mean, that's it here. I will start with a brush up of linear algebra, just a 1-hour lecture tomorrow. Any questions?
Said that program chair, area chair, reviewer process, is that for getting my paper selected in a journal or a conference?
It's a conference, but it as well, it is very similar, 95% similar in journal. In journal, the only difference is that it's a single blind review. So the reviewers know who the authors are. Otherwise, it's pretty same. I cannot think of any other difference. There is no secondary area chair sort of. So there is only the term that is used there is associate editor, not the area chair, but the associate editor, just the parallel. So there is no secondary area chair. So when the authors are, so if I go to this, when the authors send the rebuttal to the reviewers, it goes to only the primary chair. So this part does not come, and then this primary chair gives a recommendation to the editor in chief. So these chairs, they are just, the names are different, and the secondary area chair post is not there. So this is just associate editor, and this is editor in chief. Any other questions?
Maybe one basic question, sir. So when we write this supplementary section, like we have to put quite a bit of information there because not everything fits in 8 or 9 pages. So how often do the reviewers actually, look at the supplementary section?
Yeah, that's a good question. I mean, I would say in journal, almost always they check, what I have seen, my experience, because journals are a little bit slack on deadlines. So they give some 6 weeks deadlines for the reviewers. But yeah, if you ask for a 7 days or even 2 weeks extension as a reviewer, generally they give. So you have, in your own time you do. And generally that's why the common wisdom is that the reviews are robust in journal, but more noise in conferences, because that is deadline driven. And people have, and it's completely voluntary. That's what I think I forgot to tell. All these works are completely voluntary. I mean, these program chairs, area chairs, secondary area chairs, etc. They don't get money. So after doing everything, they need to do the community service, right? So maybe if there are some more pressing deadline, they will give more time there and not here. So in conferences, again, I think it comes back to how good you write your paper. So if your introduction, if your methodology, etc. are good, and you are telling that I have some results which say sheds light on this direction of the experiment, they will go and read, because they have found a good experience. I mean, they had good experience in reading your paper. They had a feel good factor, I would say. But if it's very clumsily written, then okay, I mean, I am not getting from the main paper, why should I go there to the supplementary? So in conferences, it's clumsy. I mean, I'm not sure how many of the reviewers basically see that. I do at least have a glimpse, but in journal you can expect people will do.
Okay, thank you, sir.
Any other questions? Anybody? Okay, if not, then again, welcome you again in the course. Hope you will have a good experience. So
hello, sir.
Yeah. Oh, you have some question? Yeah, please. Hello. I cannot hear. Was it Orko Provo who was asking questions? You are muted.
Yes, sir. Regarding the grading, like, is it possible to give some more weightage to the assignments?
Assignments, they have been given the most as weight, I think 60%.
Hello.
Yeah, I think yes, 60%. I mean, class test, that is quizzes are 60%, and programming assignment on are 30%. So programming assignment will be you will at least have 7 days, right? So I cannot give more more weightage to programming assignments for which you are, it's like a take home one, right? And class test is in class. Are you willing to give more weight to these programming assignments, you are saying?
So like generally in assignments, while doing things, we learn more. As far
You
as
will learn more in while reading for class tests also, right? Maybe not doing the class test. And there is very less correlation of learning with marks, right? It should be, at least ideally. Learning is different. I mean, this is so if you want to learn
because of this online mode,
marks.
class tests.
Sorry. I did not get your last
So because of this online mode, like
yeah, maybe you are dropping.
For hands-on learning, I think programming assignments are necessary. So in giving more weightage to programming assignments,
it is necessary and it is given, but that does not mean I'll replace your in-class test with the weightage of in-class test with programming assignments. You can do it by taking any other programming assignments taken from any other courses. If you want, I can give. It will not be evaluated. You just, if your whole idea is to learn by doing hands-on, you do the hands-on. I can give point to you, give the assignments, but it will not be evaluated. Any other questions?
Hello, sir. Another thing is that can we form group on our own?
No. I mean, last time we had issues, lots of issues. I'll give you time. I mean, this grouping, etc., will be done within 2 weeks, and after grouping is done, then you will have 2 weeks of time to basically go ahead. 2 and 3 weeks actually, not 2 weeks. 3 weeks of time to start. So
Hello.
we had problems of forming the team by one.
Hello, sir.
Yeah.
Sir, just a random question, like how NLP, natural language processing, is different from this DL course? Like how much part is common in both courses?
See, in NLP, what is covered, I'm not totally sure, but yeah, I mean, it will be from a DL perspective. I think I have given 2 classes on NLP applications only. So 2 lectures is just 2 hours. But these transformers, then your RNN, LSTM, they will be taught in like 2-3 lectures. So maybe I can say, I don't know whether, I mean, transformers are covered there, or I mean, RNN, LSTM definitely should be. How can I say? Maybe out of 34 classes, 4 or 5 classes. I mean, that's again a wild guess because I don't know what is actually covered in it course here, because that's not a prerequisite, right? So the prerequisite is ML. So you can have a look at the tentative schedule that has all these informations. Any other questions from anybody? Okay, if not, then again, thank you. We'll meet tomorrow at 12.